Okay, so what I'm taking you through here is comments that the examiners have made over the past few years about C1 papers. So what we've got here, they said that students didn't know that sulfur dioxide is the gas that causes acid rain. Often they talked about sulfur, but they forgot that sulfur reacts with oxygen to produce sulfur dioxide. So when you burn fuels that have sulfur in, they produce sulfur dioxide, and that dissolves in acid rain, which makes it acidic. Others thought that sulfur dioxide caused global warming, global dimming, or destroyed the ozone layer. Remember, you have to be specific about what these pollutants do. So carbon dioxide is the gas that increases global warming. Don't just say carbon dioxide pollutes the atmosphere, you need to say it increases global warming. Carbon monoxide is toxic, and nitrogen oxides cause respiratory problem, or they irritate, aggravate asthma. So here's a summary that's worth looking at. Pause now and have a look through this. Make sure you remember about complete combustion. If we've got enough oxygen around, then if we've got fossil fuels here, we're going to produce carbon dioxide and water. This word pollution, you have to be really careful about using this. You have to be specific about the kind of pollution you're talking about. Is it sulfur dioxide, which causes acid rain? Is it carbon monoxide, which is poisonous? Is it nitrogen oxides that trigger asthma attacks? Or are we just talking about the tiny solid particles, particulates? Now, it's the particulates that are the ones that cause global dimming. So be specific about what you're talking about. Now, catalytic converters are something that you can use to convert some of these gases into other gases. So here we've got carbon monoxide and nitrogen oxide, both of which we don't want. And we can convert them using a catalytic converter into carbon dioxide and nitrogen. But remember, we're still producing carbon dioxide, so we've got rid of these toxic gases, and we're producing carbon dioxide. So in effect, we're replacing one bad problem, so toxic gases, with another one, which is a gas that increases global warming. Another thing that students thought is that plants, they didn't realise that plants contain carbon, and so therefore if you've got a biofuel, which is using plants to produce energy, then they're still releasing carbon dioxide. So biodiesel is a really good resource from the point of view that we can talk about it being carbon neutral or CO2 neutral from the point of view that we're using carbon dioxide to grow the plant. They use carbon dioxide to grow, and then effectively we're just putting that carbon dioxide back in the atmosphere. But we're still producing carbon dioxide. We can produce ethanol from plants by fermenting sugar, but we're still going to produce carbon dioxide when we burn ethanol. And remember, even if we can think about things being carbon neutral in theory, the carbon dioxide coming in and carbon dioxide being released when things are burnt, it's not carbon neutral overall, because we have to produce the biodiesel, we have to transport it from place to place. So all of these things will have some kind of carbon toll with them. Hydrogen, on the other hand, hydrogen is a fabulous fuel if you can get it to work, because you're not producing carbon dioxide when you burn it, you're only producing water. But the problem with this is that obviously hydrogen is a gas, it's very difficult to store, and it's explosive. So these are all issues you have to take into account. These kind of things here, these are going to be a typical 6-mark question. You've got the pluses and the minuses here. Think about polymers. Remember when we talked about polymers, whatever you polymerize, whatever monomer you take and stick together to make your polymer, that's the way that you name it. You put the poly in front of it. So if we've got lots of pentene molecules joining together, then they form polypentane. So we start off with our monomers and we make our polymers. you have to know how to do this equation down here. You have to know that you start off with n number of monomers, and then you're joining them together to make this chain of polymers here. You can't see it here, it's actually cut off, I'm sorry about that, but you've got to learn this polymerization equation. You've got to know how you represent this kind of thing with this here, and also you've got to know the naming. So ethene joins together to make polyethene. We've got double bonds here, remember monomers have to have double bonds so that they can join with other molecules. Students didn't know that calcium hydroxide is what you produce when you react calcium oxide, with water. Now this is the limestone cycle. You've got to know the bits of this. We've got limestone at the start, we've got calcium carbonate, the chemical name for limestone. You can heat it and then we get the thermal decomposition and we end up just with calcium oxide here. But then this calcium oxide, if we add water to it, then we form calcium hydroxide. Now, if we add even more water to it, so if we're putting this calcium hydroxide in solution, this is lime water. So lime water here, you know, if you add carbon dioxide to lime water, it goes milky or you get a white precipitate. That white precipitate is the calcium hydroxide solution returning back to being calcium carbonate. Another thing is a language point, okay? You know now from your structure and bonding in C2 that when non-metals join together, they form covalent bonds. If we have covalent molecules or covalent compounds, simple covalent compounds, we call them molecules. So water is a molecule. This is ethane. Ethane is a molecule. It's non-metals joined together and we get discrete particles that are joined together in a liquid or a solid by intermolecular forces. So it's the molecules that are being held together. Remember, ethane is a molecule and it's held together in crude oil by intermolecular forces, and it's these that we overcome when we heat ethane or we heat crude oil in fractional distillation. This is different to ionic compounds where you've got ions in a big lattice that are joined together in a 3D structure, and also metals where we've got positive ions, metal ions that are surrounded by our electrons here. So it's not this 3D structure. The exception for when you come to C2 will be the giant covalent compounds. So we've still got covalent bonds in there, but we still have a 3D structure. But from the point of view where we get to is C1, we've got molecules here for our covalent compounds.